Yeah, in the previous class, what we did, we have taken two formulas, sine of a plus b and cos of a plus b. Using sine of a plus b and cos of a plus b, we derived, I think, 13 or 12 more formulae, totaling together 14 formulae. What are the operations we applied there? Sine of a plus b formula, sine a cos b plus cos a sine b, we derived it, and in that formula we replaced b with minus b, and we have got two more formulae, and adding them, subtracting them, and replacing a plus b with c and a minus b with d, and we have derived some more formulae, and dividing them we have got tan of a plus b also. Dividing them, we have got tan of a plus b also. So let us continue. Let us continue with the rest of the formula now, with the rest of the formula, which also will be deriving from, which also. So let's continue that. The division part, we did it, and we are now going for the multiplication. And then we can have cot of a plus b also, which we did not. So let me continue that. Cot of a plus b through the division. Did we write cot of a plus b, Maurya?
No, sir.
Okay. So let us see that. See, let me rewrite those two formulae first, and then we can have the rest of the formulae, and which is continuation to the previous class. Sine of a plus b is sine a cos b plus cos a sine b. Cos of a plus b, cos a cos b minus sine a sine. And this is 1, this is 2. Let me name them this side only.
Sir, you're not sharing your screen.
Array. Just a moment.
Yes, sir.
Just a moment. Yeah. Yeah. These are the formula I repeated. Sine of a plus b, cos of a plus b. Now, what is the continuation formula number, please? Should I make it 15? According to the previous class, you tell me what was the previous number?
Number, sir, it's 14, sir.
14, okay. So now 2 divided by 1, the operation I'll show in a different color so that you will have the difference. This is the operation I'm doing. 2 divided by 1 implies this is cos a plus b by sine a plus b is nothing but cot of a plus b. So you are getting the next formula, formula number 15, continuation to the previous class. It is cot of a plus b is equal to, if you divide these two, cos a cos b minus sin a sin b divided by sin a cos b plus cos a sin b, then you will get it as cot a cot b minus 1 whole divided by cot b plus cot a. Cot b plus cot a. Instead of saying it as cot a plus cot b, why I said it as cot b plus cot a, you will understand in the next formula. See, and replace b with minus b. The operation I am showing in a different color. Replace b with minus b. Then you tell me what should be the 16th formula now.
cot of A minus B
That's good.
is equal to cot of A into cot of B plus 1,
Repeat.
or 1 plus cot of A cot B.
No, what is
1 plus cot A cot B. B will be negative B, so
Yeah. You will
1
get
plus cot A cot
minus
B.
cot A cot B, minus cot A cot B, minus 1. And this is minus cot B plus cot A. I repeat, cot of minus B is minus cot B. So minus comes out here and minus 1 is there. Cot of minus B is minus cot B. And you will have minus here. Bring that minus to the denominator, or you multiply numerator and denominator with minus, so that the formula you will get it in the form of cot A cot B plus 1 divided by cot B minus cot A. That is the reason why the first formula also I wrote like that. Okay? Cot B minus cot A. So these are 16 formula we have got. Next is the multiplication. We finished with the division, no? We finished with the division. So
Yes, sir.
through division, we have got 4 formulae. One is tan of A plus B, tan A plus tan B by 1 minus tan A tan B. Other one is tan of A minus B, tan A minus tan B by 1 plus tan A tan B. Cot of A plus B, cot A cot B minus 1 by cot B plus cot A. Similarly, cot of A minus B is got by replacing B with minus B. Cot A cot B plus 1 divided by cot B minus cot A. If you concentrate when I'm teaching, no? When I'm teaching, then when I'm telling you the technique, if you concentrate now itself, you need not have to see them again. You can easily understand that. Okay. Now we have done with addition, subtraction, and division. Now the remaining is the multiplication. So for the multiplication, you must know the 3 and 4 formulae also. That is, we have got 3 and 4 by replacing B with minus B, and that is sine of A minus B is nothing but sine A cos B minus cos A sine B. Similarly, replacing B with minus B, you know, you said this formula just now. I asked you, is cos of A minus B is cos A cos B plus sine A sine B. So what is that we have to multiply now? In the division, we have taken 1 and 2 directly. In the subtraction, we have taken 1 and 3. And addition also 1 and 3, 2 and 4, like that. We have taken an order like that. Here, in multiplication also, you have to choose sine A plus B, sine A minus B. So, what is that to be done? What is the operation to be done? 1 into 3, comma, 2 into 4 implies, come on, tell me that. Sine of A
Sine
plus
of
B.
A plus B into sine of A minus B.
Write the formula number. We done with 16. I think it is 17, no?
Yes, sir. 17, sir.
Yeah, sine of A plus B into sine of A minus B. See, just if you observe carefully, now it is in the form of sine of A plus B into sine of A minus B. If you multiply on right hand side, it is A plus B into A minus B. What is A plus B into A minus B, please?
A plus B is A plus B into A minus B is A square minus B square.
Correct. So what I do, the simplification part, I'm doing it here in another color, and we will be writing the result finally here after doing that. Come on, tell me now. A plus B into A minus B. What is it? Sine square A.
A square, sine square A cos square B plus A square minus B square. That's my cos square A sine square B.
That's good. Right. Now, I want to convert this to totally in terms of sine. Then what I'm doing, I'm writing cos square B as 1 minus
sine square B.
Similarly, cos square as 1 minus
1 minus sine square A
into sine square B. Okay? If you expand it now, what is that? You're getting sine square A into 1. Sine square A minus sine square A sine square B minus 1 into sine square B minus of minus plus sine square A sine square B. Check it out. What are the terms getting cancelled here? The terms that are getting
sine
cancelled
square B.
are sine square A sine square B negative and sine square A sine square B positive, getting cancelled. So what are the terms remaining now? Sine square A.
Sine square A minus sine square B.
The formula to be noted for sine A plus B into sine A minus B is sine square A minus sine square B. And even you can write it in terms of cos also, which is very much essential in solving the problems. Like what? We write sine square A as 1 minus cos square A. We write sine square A as 1 minus cos square A, sine square B as 1 minus cos square B. Then if you convert it to cos, you will be getting it as cos square B minus cos square A. So through multiplication, you are getting this formula. Through multiplication, you are getting this formula, which is sine A plus B into sine A minus B is equal to sine square A minus sine square B, or even you can write it in the terms of cos also, cos square A minus cos square B minus cos square A, cos square B minus cos square A. This is a simplification part. This is a simplification part just for you to give you the logic. Even whatever the methods we are applying to derive this formula will be very much useful in solving the problems also. That is why I'm teaching you like that instead of giving the formula directly. Okay, that is 71. Now, what is 2 into 4? Similarly, you will have 2 into 4 means this is cos A plus B into cos A minus B. Can you do that? Can you try that? Cos A plus B, cos A cos B minus sin A sin B, cos A minus B, cos A cos B plus sin A sin B. Come on, tell me what is the step to be written there. I'm erasing this and I'm taking the space to derive that next formula, which is cos of A plus B into cos of A minus A. Very much similar to this only. Only thing is, you will have
Sine will be cos.
Sine into cos here, but here cos into cos. Here cos into sine is a sine into sine. That's only the difference. So come on, tell me what should be written here?
Cos of A plus B,
plus B
into cos of A minus B.
Let us do its working separately before writing the
A
formula.
square minus B square.
Yes, tell
That's
me.
a cos square A, cos square B minus sine square A, sine square B.
That's good. Now, what I'm trying to do, I want to express the formula only in terms of cos. So I'm keeping it as it is because I want to convert it to the terms of cos only. So I'm writing it as cos square A, cos square B. I'm converting this as 1 minus cos square A into sine square B can be written as 1 minus cos
1 minus sine cos square. Yeah.
Cos square B. Okay. Let us expand it. Come on, check it out once. Cos square A, let us multiply this. What is that you get? What is that you get? Multiply.
A plus A minus B into A minus B. It's A minus B whole square. That's A square minus 2AB plus B square.
Cos square A, cos square B minus 1 into 1. 1.
AB 2.
No, multiply this. 1 into 1. 1. 1 into
okay, that way. So we can use A minus B the whole square formula, right?
No. This is A, this is B.
Okay. All right.
We cannot do that. 1 minus cos square B. This is minus cos square A into 1. Minus cos square A. this part, minus cos square A. This is minus into minus plus.
plus uh, cos
Cos
square A,
square
cos
A,
square
cos.
B.
Okay, so what are the terms getting cancelled here? Cos square A, cos square
Cos
B.
square B, negative cos.
This is negative cos square A, cos square B getting cancelled. So what is that remaining now? You have got
Uh,
1
minus
minus
1
cos square B can be written as sine square B, and minus of minus plus here.
plus cos
You will
square A.
not get the like this. The uniformity will not be there. Both in sine, both in cos, you don't get here. You tell me, minus of minus plus here. So that becomes cos square A. And this is 1 minus cos square B. 1 minus cos square B is
Sine square B.
this is one formula. And you can even convert this in the other way also. You can write it as 1 minus sine square A. You can write it as 1 minus cos square B. 1 getting cancelled. Then you will be getting it in the form of cos square B minus sine square A also. Just observe it.
Yes, sir.
So this is through the product, you can derive two more formulae which are important. And don't think that this trigonometry finishes only in 11th. This trigonometry finishes only in 11th. Not at all. You will have to apply this throughout the calculus. You will have calculus, differential calculus, integral calculus, and to solve the problems, solve the problems that are in calculus, differential and integral calculus, you need to have the knowledge of trigonometry. You need to know the formula of trigonometry. Otherwise, it is not at all possible to solve those problems. So, trigonometry, you have to understand, it will be used in all other topics. Okay. So there is a little confusion in cos A plus B into cos A minus B because there will be no uniformity for that. It is a combination of both sine and cos. But sine A plus B into sine A minus B, you have the uniformity like sine square A minus sine square B. Cos square B minus
Cos square B minus cos square A.
Here there is a
Over here, cos square B minus sine square.
So here these are now 18 formulae we derived, and a very important point to be remembered. Logically, I taught you this. Through the logic, we have derived 18 formulae, that is including these two formulae. We used only these two formulae to derive all these 18 formulae. And up to this, we call them as compound angles. These are called compound angles. Okay.
Yes, sir.
Next is multiple and submultiple angles. And from this one, then you must think like this. Sir, is it possible to derive sine of A plus B plus C? Yes, we can. Is it possible to derive tan of A plus B plus C? Yes, you can. How? I'll give you just a hint. Anyway, we'll be doing that in the problems. That is why you need not have to remember them as formulae, but you must know how to do them, how to solve them, how to get those three angles. Now, whatever the angles we have taken so far are only two angles, A and B. And if you go for three angles, how to proceed? How to proceed? Very simple only, very simple only. Like what? The formula sheet, what I gave you, the synopsis, in that one, you will find this. You will find this. What is that? I'm telling you that don't take it as a formula, but take it as the instruction. Like what? If you want the expansion of sine of A plus B plus C, for example, then you take this as A only, take this as B, that's it. This is A, this is B. Then what is sine of A plus B formula? sine A cos of B plus C plus cos A sine of B plus C. Do you understand what I'm saying? Similarly,
Yes, sir.
cos of B plus C, you expand the formula. Apply the formula for cos of B plus C.
Okay.
Cos B,
Cos
cos B.
B plus cos C. I
Come
mean
on, tell me.
minus sin B sin C.
Similarly, plus cos A into sine of B plus C formula.
Sin A sin B plus co- sin A sin B cos C plus cos B sin C.
That's it. If you expand it, you'll
Tradi-
get sine of A.
Traditionally, we use A and B,
Yeah,
so this time B and C is a little
time.
confusing.
It will take time for you to habituate. And if you expand this, you will be getting sine of A plus B plus C. Like that, these two angles can be extended to 3 angles, 4 angles, like that. Whatever the sheet I gave you, it is extended for n angles also. But n angles generally in the higher level only we'll be using. But up to 3 angles, it is sufficient for us. Okay. So this is compound angles and the transformations. First part is transformations also I taught you in the formula number 5 to I think 12, 5 to 12 we have taken transformations. Transformations means sum to product, product to sum. That is called transformations. Now next is multiple and submultiple angles. Next topic is multiple and submultiple angles, and I don't think it is mentioned separately with this name in your CBSE, that NCERT textbook, but it is to be taught like that only. They have mixed up all the formulae, but if you see the trigonometry topic in the books, you will find subtopics as first one trigonometric ratio, second one compound angles, third one this one multiple and submultiple angles. What is submultiple and multiple? Very simple is that multiple means if you have 2A, 3A, 4A, like that, these are said to be multiples, 2A, 3A, 4A. These are said to be multiples, and submultiples means A by 2, A by 3, A by 4. That means division. You'll have a fraction. Then they are said to be submultiples, multiples and submultiples. That's it. So this is also again, all the formula of this also again derived from only two formulae. This logic is to be understood, please. This logic is to be understood to remember the formula very easily. To remember the formula very easily. So what is to be done to make it 2A? Can you imagine? I want to make this A plus B 2A. Then what is to be done?
A is equal to B.
Repeat. That's good.
A is equal to B.
Replace B with A otherwise. Same. Whatever you are saying is same. Then what happens? You will get two more formulae. Come on, tell me the number 18 we arrived already.
19.
19th formula. Sine of A plus A. I'm writing that directly. Sine of A plus A is sine 2A, and this becomes sine A cos A plus cos A sine A. Sine A cos A plus cos A sine A, 2 sine A cos A. Got another formula. Should I repeat? Replace
Yes.
B with A. This becomes sine A cos A. And this becomes cos A sine A. Both are same terms only. Sine A cos A.
So 2 sin A cos A.
That's what I wrote. That's what I wrote. Okay. Now it can be converted. It can be converted to tan also. Like how I'm showing the derivation here. This 2 sine A cos A can be written as, I want to convert this to tan. if you have sine, no, to convert sine to tan, you must have cos A in the denominator. But cos A is not there, divided and multiplied. Correct, no? This 2 sine A cos A taken. This is divided with cos A and hence multiplied with cos A. And again, this only remains, no? So,
Yes, sir.
what is sine A by cos A? Tan A. What is cos square A in the denominator, please? Shift that cos square A to the denominator. Reciprocal.
Sine sec square A.
Yes.
1 by cos square.
So tan A upon, what is the identity of secant square A? 1 plus tan square A. You know that? You have in
Yes.
10th class itself. So what is the other formula for this? And what is the advantage of this? You will have the entire formula in terms of, you'll have the entire formula in terms of tan only. So 2 tan A upon 1 plus tan square A. Okay? So this
Yes,
is
sir.
what the first multiple and submultiple formula. And why I said and submultiple, because you need not have to learn submultiple separately. You need not have to learn submultiple separately, like how I'll tell you that. See, if you want to get submultiple, no, very simple, replace 2A with A. I repeat, we want to have the same formula converted to submultiple. Replace 2A with A. Okay. Then
Okay, sir.
you tell me, if I'm replacing 2A with A, then what is the replacement of A then?
A by 2.
That's good. That's good. It is done. It has become submultiple. Just see that. Similarly, you tell me this also.
2 tan A by 2 by 1 plus tan square A by 2.
2 tan A by 2 upon 1 plus tan square A by 2. That's it. So this is the first and foremost formula in multiple and submultiple angles. Sine 2A is equal to 2 sine A cos A is equal to 2 tan A by 1 plus tan square A. And submultiple, of course, you need not have to learn separately if you remember this, that sine 2A itself is taken as sine A, 2 sine A cos A is taken as 2 sine A by 2 cos A by 2, and thereby this 2 tan A by 1 plus tan square A becomes 2 tan A by 2 by 1 plus tan square A by 2. And next is 20th formula. I'll say it is a 5-star formula. You know, nowadays everything is counted with rating, no?
Yes, sir.
Rating. Single star, double star, triple star, up to 5 stars they are counting. Now what I say, no, this you will get cos 2A formula, no? Next one, no? I'll give 5 stars to this formula. That much important it is, which is very comfortably used in all the remaining topics. That is the reason why there is a more and more prominence for this formula. It is a 5-star formula, cos 2A. I'll be deriving that in the next class. But till then, whatever we have derived, just remember them, cos 2A, I'll be deriving in the next class. Okay, is it okay up to this?
Yes, sir. Yes, sir. Totally okay, sir.
Yeah. Now, let us see 2 to 3 problems and then we'll close the session. Just see this. It is cos A, cos B minus sin A, sin B. It is to be proved like that. So let us consider LHS. LHS is equal to, come on, tell me. I'll do one thing. For the sake of comparison, I'm writing the formula so that you will be more comfortable. The formula, what I'd like to write here, according to this, is cos A cos B minus sin A sin B is equal to what? Cos of A plus B. Correct or not? Do you remember this?
Sir, in the yes, sir. This one I remember, sir. But in the question it's given sign. Okay, we have to prove. Fine.
Now, that's what I said. Never see the formula only from one side. See the formula from both sides. If it is seen only or understood or remembered only from one side, you'll get confusion. So now let us see the comparison here with this formula. This is A, this is B, again this is A, again this is B. So what is to be written in terms of in place of A? Pi by 4 minus x. What is to be written in terms of B? Pi by 4 minus 5. That's it. Nothing other than that. Okay. So let us write now LHS. LHS is equal to cos of, I'm writing that for the better
So
understanding.
just excuse me, sir. I'm just not.
Yeah.
Yes, sir.
Now you can see, I wrote LHS there. Now in place of A, you have pi by 4 minus x. In place of B, you have pi by 4 minus y. So what is to be written? It is in the form of cos A, cos B minus sin A, sin B. Then what should it be? Cos of A plus B. Come on, tell me, what is A here?
Pi by 4 minus x.
Very good. What is B here?
Pi by 4 minus y.
That's good. What is pi by 4 plus pi by 4?
Pi by 4 plus pi by 8.
Pi by
8.
2
Oh,
pi
wait, 2 pi by 4. 2 pi by 4.
means pi by 2.
Yeah.
Correct now?
Yes, sir. Yes, sir.
Minus x minus y. I'm showing it as a line bracket. This is minus of. This is called line bracket. You know Bodmas rule, no?
Yes, sir. Yes, sir.
Bodmas rule. In fact, we must call it as L Bodmas. L stands for line bracket. Generally, that line bracket is neglected. This is line bracket. Don't get confused. Line bracket means
Yes, sir.
while splitting it, you have to write as minus of x plus y. Minus x minus y. Now, what is cos 90 minus theta?
Cos 90 minus theta is sin theta.
That's it. Which is RHS, and it is proved.
Oh,
That's it, please. Hope you understand what I wrote there.
yes, sir.
Yeah.
Yes, sir. Totally, sir. Yes, sir.
Yeah. Now what we do, we'll continue with the other problems in the next session.
Yes, sir.
Okay.
Okay, sir.
But before that, whatever the formula I taught you today, you learn them by next class, and we'll be continue with the rest of the formulae. Whatever the things we are doing, we are learning all those formulae only through
Sin A plus sin
Two
first
formula.
formula.
Only through two formulae. What are those formulae? Sin
Sin
of
of A plus B and cos of A plus B.
cos of A plus B. Okay. So
Yes, sir.
next remaining formula also we are doing in the same manner. Same manner.
Alright, sir.
And we did up to 20. Yeah? What is the number we did?
20, sir. 20, sir.
Up to 20. And we will be continuing with the other formula. That is done. Then that will be done. Then we will move on to finish off the entire exercise.
Alright, sir.
So, see you in the next session. Bye, Maurya.
See you, sir. Bye, sir.